Today we're going to talk about function notation. We're going to explore a brand new notation called f of x. We can also say that function of x. That means an equation that has the variable x in it. F of x is basically a fancy name for y. So remember, f of x is going to go back and replace y in our equation. There's a little more to it than that, so let's get to it. So anywhere you see the variable y, you can replace it with f of x. So if I have an equation that looks like y equals x plus 3, now I can change it to f of x equals x plus 3. These are the same equation. What would y equals 2x minus 4 look like in function notation? If I replace y with f of x, it would look like f of x equals 2x minus 4. We have a problem though. We have some equations when y is not isolated or by itself. So go back and remember, we learned to rearrange equations to isolate a certain variable. We're going to add, subtract, multiply, and divide to manipulate those equations to get y by itself so we can turn it into function notation. So here I have 4x plus y equals 8. Y is being added. Sorry about the announcement. Okay, so remember y is being added to 4x to equal 8. When I do that in reverse, 8 will now be subtracted by 4x, or 4x will be subtracted from 8 to give me my equation. So I can write it as y equals negative 4x plus 8, or I can write it as y equals 8 minus 4x. Either way is fine. Slope-intercept form is a little better, however. And now I can rewrite that equation in function notation either as f of x equals negative 4x plus 8 or f of x equals 8 minus 4x. Both are good. Let's try just a couple more of these. Let's start with 12 plus y equals 11x. What do I need to do to get y by itself on this side? I need to subtract 12. So that's exactly what I'm going to do. These 12s will cancel. Y equals 11x minus 12. And now that I need to turn that into function notation, now I can call that f of x equals 11x minus 12. Remember, I can't change it into function notation until I have y by itself. In my second equation, y minus 4 equals 7x. To get y by itself, I would have to add 4 to both sides. These 4's will cancel. I have y equals 7x plus 4. Remember, x's and non-x's cannot be combined. So now I can change it into function notation. F of x equals 7x plus 4. Next one, 2x minus y equals 17. I am going to put the 1 in front of my y. So now I'm going to say y is, first of all, it's being multiplied by negative 1. Because this 2x is positive, I can say it's being added to 2x to equal 17. So when I take this in reverse, I'm going to start with 17. Now I'm going to subtract 2x. I'm going to divide by negative 1 to equal y. I need to simplify this before I can do anything else. So I'm going to take negative 2x divided by negative 1. Negative over negative gives me positive 2x. On this side, 17 divided by negative 1 gives me a negative 17. That's going to equal y. So now to change it into function notation, instead of y, I'm going to write f of x. f of x equals 2x minus 17. I have an equation or a function with a variable x in it. In this last one, I have 3y equals 10x plus 6. To get y by itself, I have to divide by 3. If I divide one side by 3, I have to divide everything by 3. These 3's will cancel. I get y equals, I have to simplify the other side. 10x divided by 3. I can't simplify a 10 divided by 3, so I leave it as 10 thirds x. And 6 divided by 3 gives me a positive 2. Now that I have this simplified, I can change it into function notation. F of x equals 10 thirds x plus 2. Make sure you write down any questions so you can bring them to class. Have a great day, and I'll see you later.